Hello everyone, and welcome to Island Technology's presentation covering quality of service, known as QoS in DrayTek Routers. My name is Rudy Tan, and I am Network Engineer at Island Technology. Together with Roy Panetta, who is the Technical Manager at Island Technology, we will give an overview of the QoS feature in the DrayTek Routers and how it is used. Some housekeeping issues. The presentation will be around 20 minutes, and there will be a 5-minute Q&A. Listen-only mode for the presentation, and you can raise your hand in a Q&A time. You can type your questions or comments in the left bottom. Sometimes there may be breakage in sound due to network congestion. Be patient and stay on. Sometimes you may have to re-register to get back in. We will save a recorded video on our blog site sometime in the future. But if you want a particular slide, you can click Save button on the page. I will now pass to Roy to tell you more about QoS.
Hello everybody, my name is Roy Panetta, and today I'll just explain what quality of service is and how it's used in DrayTek Routers. Firstly, I'll just go over the agenda for today's presentation. So first we'll look at what is quality of service, and then we'll look at why we need quality of service, and then we'll follow this by quality of service in DrayTek Routers. And then we just go through some of the configuration options for quality of service in DrayTek. And then finally just look at a quality of service configuration example, which is based on one of the application notes from DrayTek. So we'll just make a start. And so we'll just start by looking at what is quality of service. So here we've got a definition of what QoS is, and it says that quality of service is the ability to provide priority to different applications, users, or data flows, or to guarantee a certain level of performance to data flow. And that's just a standard definition for QoS there. So what this means is that some applications or data flow cannot be delayed or interrupted in a busy network. So one application may be more important than others. For example, VoIP traffic cannot be interrupted since it occurs in real time, and it will be difficult to carry out a conversation if the voice transmission keeps dropping out. Or another example could be maybe you want to say access to the finance system may be more important than browsing Facebook and so on. So now we just look at why we need quality of service, and I think I covered some previously, but we look at what factors influence data flow, and these are reliability, delay, jitter, and the available bandwidth. So the lack of reliability usually means that data packets can be lost. So for TCP/IP communications, it will result in slower transmissions since the packets have to be retransmitted. But for UDP packets, which is used for VoIP communications, it will just result in dropouts, which will cause broken audio. And the next item was delay in data flow. It'll be noticeable for real-time applications such as VoIP. And then we got the other factors which influence data flow, which are jitter, which is a variation of the packets belonging to the same data flow, and the bandwidth requirements. Some applications may need more bandwidth than others. So, for example, a video stream will require much higher bandwidth than a web page. And insufficient bandwidth for a video stream usually results in buffering and the stop-start video stream, which can be disruptive. So in IP networks, quality of service is used to prioritize critical traffic over non-critical traffic. So for example, you may want VoIP traffic to have higher priority than email or HTTP traffic. And since the internet is a best effort service, there is no guarantee that packets will not be dropped due to congestion or be unduly delayed. So for real-time applications such as VoIP, video over IP, they'll work okay when there's sufficient bandwidth. But during peak hours, when you get network congestion, this can result in increased packet loss and delay, which results in degraded VoIP services and so on. So now I'll just look quickly at quality of service implementation in DrayTek Routers. So in DrayTek Routers, there are two components which are used in the primary configuration of quality of service, and these are, which are listed there, is this classification, which is used to identify low latency or crucial applications, and marking them with a high priority service level enforcement throughout the network. And the other component is scheduling, which is based on the classification of the service level. So it can assign packets to queues or associated service types. And in DrayTek Routers, the primary configuration of quality of service is effective under heavy traffic load conditions. So, for example, if the WAN connection becomes congested, then the data requiring priority has to compete with other data. So with DrayTek, it'll dynamically allocate the required bandwidth for high priority data. So, and I'll go through some of the configuration options later. And also, it's worth noting that quality of service is not to be confused, to be confused with bandwidth rate limiting, which has the effect of slowing down the PCs, but it doesn't prioritize, data traffic. And for large-scale network implementation of quality of service, the usual method is to use a differentiated service code point, which is also known as DSCP, and IP precedence at layer 3. With the DSCP, you can create 64 classes, and it's backwards compatible with legacy systems, which is the type of service field in the IP header to define 8 service classes. So just a bit of background on the theory. So you've got differentiated services, or DiffServ, provides a method to classify and manage network traffic to provide quality of service in IP networks. And as you can see, I've just shown the DiffServ uses a 6-bit differentiated services code point, which is DSCP, in the 8-bit differentiated particular services DS field in the IP header. And it's used for classification purposes. And the last 2 bits are not currently used. So it's just a header which is put into the data packets, and it classifies the priority of the data. And in this diagram, just shows the QoS enabled network, or differential services, or DiffServ DS framework. And that's for like a wide area type setup. You got you require higher value, quality of service around the whole network, except from one endpoint to the other endpoint. And here, each network provider has an agreed level or service level agreement to guarantee end-to-end service level. So the appropriate quality of service settings have to be enabled across the whole network to give priority to a particular type of network traffic, such as VoIP traffic. And each DS domain will prioritize this traffic, and this is known as per hop behavior, or just PHB. So it's got an example of this is how Telstra prioritizes VoIP over the NBN. They use, I think, DSP 46 to take VoIP packets across the network. So when you plug in a device into their, like the NBN connection for VoIP, it's got that setting already set up end-to-end on the Telstra network. And on this slide, I just show that the per hop behavior is a term used in differentiated services and it defines the policy and priority applied to a packet when traversing a hop, such as a router, in a diff-serve network. And here we have just some examples of the DSCP bit settings. So you can say that all zeros is used for best effort, and the second example, just another one which conforms to requirements of a particular application. So here we've got the definition of per hop behavior. It includes expedited forwarding, which is EF, and short forwarding, AF, and best effort, which is BE. And you'll see some of those in the DrayTek configuration options. And in the table you can see the assured forwarding defines there's 4 classes of delivery or forwarding classes and 3 levels of drop precedence in each of these classes. And these are the low drop, medium drop, and high drop. And the combination of classes and drop precedence gives us 12 separate DSCP encodings from AF11 to AF43. So, and here we've got, so prior to diff-serve, IP4 networks could use the precedence field, which is in the type of service field. And it's a byte in the IP4 header to mark priority traffic or traffic priority. And the first 3 bits are the precedence bits, which are mapped to a diff-serve class. So we have CSO 0 equals to IP precedence 0 and CS1 to IP precedence 1 and so on. So you probably don't need to know much of this anyway, but and if the packet is received from a non-diff-serve aware router, they use IP precedence markings. The diff-serve router can still understand the encoding as a class selector code point. So I'll just show you, I don't know if you can see this one. This is a screenshot from the 2860. So in the DrayTek routers, they have 20 pre-configured diff-serve code points that can be selected for the QoS setting. So these include the 7 IP precedence classes, which goes from, I don't know if you can see, from IP precedence 1 up to 7. It doesn't include 0, which is the best effort. So they left that one out. And then you've got the AF classes, which is 12 of those that we mentioned previously. So now just quickly go over some of the configuration options for QoS in DrayTek routers. For DrayOS routers such as the Vigor 2860 that I've got shown here, the QoS settings are done in the bandwidth management and quality of service configuration menu. And you'll notice there's 3 sections on this page. So so at the top we've got, I'll just go to the next one so you can see it better. So at the top we've got the general setup menu, and here we can configure QoS for each WAN interface. And you notice that we have 4 categories for bandwidth allocation. There's class 1, class 2, class 3, as well as others. And you allocate the bandwidth for those. And then if we click on the setup option for each WAN interface, we can enter the percentage of the bandwidth to reserve for each class. So you've got class 1, 2, and 3. So the default settings are 25%, but you can adjust these to suit your requirements. So however, the total of all these values need to add up to 100%. Otherwise, it won't let you save the configuration. And you should note that the bandwidth allocation is dynamic. So if the reserved bandwidth is not required for the specified application, it will be used for other internet activity. But as soon as the WAN becomes congested, then that's when this comes into play, and the router will dynamically allocate the required bandwidth for the application selected. And another option on this page is the UDP bandwidth control. So if you're running VoIP services, it's not recommended to enable this option, as it will seriously impact communication, since it uses UDP. So it'll start dropping VoIP packets if you turn that on. So normally we leave that off if you're going to be using VoIP. And you'll notice that you can also select the direction for the QoS control. And this can be, I don't know if you can see here, it's got a box, then you've got in, out, or both, which is both in and out. In the next section of the quality of service configuration menu is the class rules. And here we create index class to include the service types and IP addresses to be included. So I'll just show you more detail. So if you click on the edit option for the class, then you click on add rule, and as you can see, you can enter the local and remote IP addresses that this rule applies to. And then you can also select one of the pre-configured service types from the pull-down list that I've just shown there. And if the service type's not in the list, you can create your own by clicking on the edit option, and then just have your customized service type, which could be a particular port or application. So here I think we've got selected HTTP port 80 in blue there. And you could also select one of the, so just from the pull down list I've got highlighted there, just select one of those from the pull down to use for your configuration. So I think here I've just shown the edit. I think I've just shown this one previously. And on this one, let me have a look here. That's right, I got boxed in for the later firmware releases. It's since last year, I think all the new firmware, what they have now is a pre-configured option for quality of service for VoIP traffic. So instead of just configuring within setting up a service class, and you just tick this box and it'll automatically set up the required services in the background. And all you need to do is just select the CPU DP port, which the default is I think 5060. And one thing you should know that when you set up quality of service, in order for quality of service to work correctly, the router needs to know the actual bandwidth for the WAN connection, because it uses this to determine how much bandwidth to allocate. So for ADSL WAN connections, the router can work out the actual upload and download speeds, but for Ethernet WAN, the router could be connected to an external modem, which might provide much lower bandwidth than the capacity of the router WAN interface. So here we need to enter the actual upload and download speeds. And to work this out, you can just run a speed test or use some other utility to check your internet speed. And then we just run it a few times. And then, so I've got the one example just to use speedtest.net. To go to the internet, just run it a few times and just take the averages. And then normally, I'll just show a picture of the speed test results. And what you do is just take 80% of the average measured speeds and use that as the value to enter into the the router settings, and that'll maximize the quality of service performance. And then finally, with the later firmware releases, you can also apply the QoS in the firewall rules as well that I just got highlighted here down the bottom. So that's in our latest firmware. They've got that option as well. So now I'll just go quickly over a quality of service configuration example. And this is based on an application note on the DrayTek website. And here I'll show you how you can set up quality of service to reserve bandwidth for a VPN connection. So we want to give priority to traffic going from the FTP server, which is on the right-hand side. Actually, traffic going to the FTP on the right, which is 192.168.20.11. And that's for traffic coming from the left-hand side, which is on the 192.168.10.1 subnet. That's on the left-hand side. So we've got a VPN connection. We just want to prioritize traffic over the VPN to that particular server. So the first step is to log into the VPN client router, which would have been the left-hand side router. And then go to bandwidth management, quality of service configuration menu, and edit class 1 in the class rule. So I've got that just shown in red around the box. Then the next step is to to enter a name for that particular rule, and then click Add to create the new rule. Then the next we need to select ACT, which just activate that rule, and then enter the local and remote IP addresses shown in B and C. So on the right-hand side, just click on the edit and enter the IP address for each end. And then next we enter the IP subnet for the VPN client side, and then the IP address for the VPN server end. And then next step is just to set up quality of service for WAN 2. So we click on the setup, and that'll take us to the next menu, which I've just got shown here now. And so we select QoS control for outgoing traffic. So we select out. And we also need to specify the actual WAN bandwidth for WAN 2. So here we entered 512 kilobits per second as the outgoing bandwidth speed. And then once the configuration is completed, and the VPN is running, we just click on the status option, and then look at the traffic details. So you should see something like this, what's shown here. So here we got the green bar just shows the VPN traffic, and it should have, should see traffic appearing in a sort of manner, and the length of the bar indicates the amount of traffic being prioritized for WAN 2. So you got VoIP, you got VPN traffic, and you got others. So that's what it's required. But there is a detailed application out on their website that you can look at as well. So for more information on quality of service in DrayTek routers, it's available from our support website, which is www.draytek.com, and also www.draytek.com.au. And also for product information, you can send an email to support@draytek.com.